Section 2.5 is about the chain rule. So the chain rule is a rule for taking derivatives of certain types of functions. We saw at the end of the last section that we took a derivative of 3x squared plus 8 quantity squared. And what we ended up with is 3x squared plus 8 to the first power multiplied times 12x. That 12x happened to be 2 times the derivative of this 3x squared plus 8. Now, we also found the derivative of sine times sine, but let's go ahead and see what will happen if we have g of x is equal to sine to the third. We're going to find the derivative using the product rule here. So I'm going to look at the g of x as sine times sine times sine. If you remember, we took the derivative of 3 functions being multiplied times each other, and we said, well, it can be the derivative of the first one, then times the normal second and third, plus the normal first times the derivative of the second times the normal third, plus the normal first times the normal second times the derivative of the third. Now, in this case, notice that since sine, sine, and sine were all repeated, we end up with a derivative, which I can rewrite as g prime of x, which is equal to 3 times cosine of x times sine of x squared. Observe what's happening here. We had sine to the third power. One way we can look at it is we can see that this exponent came out front, that 3 came out front, and I lowered my exponent by 1 degree. Then I have to multiply a derivative of the sine. So that's cosine. This should remind us of our power rule. Remember, our power rule says that if I want to take the derivative with respect to u of u to a power, what I should do is take n times u to the n minus 1 power. And so if I have a derivative with respect to u, I do that. Now, we saw that as with respect to x, and we had an x in here instead of a u, but later on we'll be using the letter u. So we took the 3 out front, then I multiplied, or excuse me, then I decreased the exponent by 1, and then I multiplied times the derivative of the inside function. So it looks like our power rule with this extra multiplication of our inside derivative of the inside function. What we're doing in that example is essentially a composition of functions, an f and a g. Now, I know it's unfortunate that I called my previous function g of x, but think of this as a new f and a new g, all right? So it's a composition of an x to the third with a sine of x. If I take the composition of f and g, what I need to do is I need to plug in the g of x, the sine, inside of my f of x, my x to the third. So I'm getting a sine to the third power. It's a composition of f and g. If I have a composition of functions, that's where this chain rule can be applied. So here's what the chain rule says. Let f and g be differentiable functions on appropriate intervals. Then f composed with g is a differentiable function, and the way you can find the derivative with respect to x of the composition of f and g is by taking the derivative of f composed with g multiplied times the derivative of g. The way I say that is take the derivative of the outside function, where your inside function stays the same, and then multiply times the derivative of the inside function. So multiplying times the derivative of the inside function. That is the chain rule. So let's apply the chain rule to this g of x we had earlier. So this is a composition of something to the third power. Let's just make some notation. Let's say we have u to the third power. And if I want to take a derivative of u to the third, let's say y equals u to the third. I know that y prime is going to be 3u to the second. So I start by doing that. This outside function is something to the third power. So when I take a derivative of g with respect to x, I want to get 3 times that sine to the second power. And then lastly, the inside function, sine of x, has derivative of cosine of x. So after I take 3u squared, where u is the inside function, then I have to take and multiply times cosine of x. I can rearrange the multiplications if I want to make it exactly what we got earlier, 3 cosine times sine squared, or 3 times sine squared times cosine. Now, you'll notice that I'm using a u here as a stand-in for my sine of x. When you do that, oftentimes what you'll see is the chain rule written this way. So some people will write the chain rule using u's. And the way they write it is derivative with respect to x of f of u is equal to f prime of u times u prime. So instead of g's, people will use u's. Sometimes this is easier for people to understand because there's a single letter there that replaces my inside function. In my case, this was sine. Let's apply the chain rule to different functions. So we're going to apply the chain rule to different functions, in particular this capital F and this capital G of x. They are both polynomials inside of a power. So polynomials inside of a power. So our outside function is going to look like a power rule. And our inside function, we can take the derivative of using rules of polynomials. Let's examine this capital F of x first. So I like to think of this as dealing with an inside function of, I'll call it u. This would be sort of like a 7u to the 5th. That's my outside function, and my inside function of u is going to be 12x to the 3rd minus 7x. So if I take a derivative of y, I'm going to end up with 35u to the 4th. And in my case, my u happens to be 12x to the 3rd minus 7x. And therefore, my u prime is going to be 36x squared minus 7. Now, one thing I didn't do, a lot of times what people will do is up here in their y prime, they will put this multiply times the inside function. And that's what really our f of x is going to be. It's going to be, when I said f of x, I meant f prime of x. Our f prime of x is going to be 35u to the 4th times u prime. And we've just seen that my u here is this 12x to the 3rd minus 7x. So I can replace that u with a 12x to the 3rd minus 7x. And I can replace this u prime with a 36x squared minus 7. Again, order of multiplication is not important. So I could take the 35 and multiply it into this term. I could take this term and write that out front, or this multiplication and write that out front. So order of multiplication is not a big deal so long as we have all three parts. Hopefully that makes sense. Let's take a look at g of x. Now, if g of x is thought of a function, it's thought of as 9 times u to the 9th, where our u is equal to 4x to the 5th minus 8. If I take a derivative of the outside function, it will be 81u to the 8th times u prime. If I take a derivative of u with respect to x, I'm going to get 20x to the 4th plus or minus 0. The chain rule says that my g prime of x will be 81u to the 8th times u prime. And when I do my substitution, that means g prime of x is going to be 81 multiplied times 4x to the 5th minus 8 to the 8th power multiplied times 20x to the 4th. So there you go. Again, we want all three pieces if we're going to find the function correctly. And once again, if you want to rewrite this, a lot of people will say, well, since 81 is a single term, and since 20x to the 4th is a single term, you could technically rewrite that g prime of x as, we'll take 81 times 20. 81 times 20 is 1620 x to the 4th multiplied times 4x to the 5th minus 8, all to the 8th, or to the 8th power. So I just took the 20x to the 4th, multiplied it by 81, and I got this component. So a lot of people clean it up that way. And that way you have less terms to deal with. So that's how we utilize the chain rule, where I have a function inside of a power. Function inside of a power, whether that be that inside function is a polynomial, or like in the previous example, whether that inside function was a trig function like sine. What I would like you to do is the following two problems. There are two functions here, and I would like you to find the derivative of these two functions utilizing the chain rule. Go ahead and do that. Push pause on these videos.